So, and basically today we will talk about some like other iterable objects, which are two-dimensional lists, dictionary sets, and it's pretty important in my mind, especially because at some moment we will, or you will make a switch from the just like plain default data types in Python to some advanced, and they still share some similarities between each other. So when I'm going to create a week 5. So and basically two-dimensional list is a list of lists. So do you remember, guys, lists? It's like a collection which are mutable, and then also you can put like different data types as the elements of the two-dimensional list. And let's just create the first example. So and the idea is like, as you remember, so if we have like list, we can put some elements, right? But I didn't say that we should just like put integers, floats, or strings. In reality, we can put like another lists inside of it. So and let's call it like as a m. And then, for example, we can put as a first element of our list another list, something like that. And then like second element going to be 4, 5, 6, for example. And now this is our first element inside of the list. And basically this is a two-dimensional list because we have like kind of first dimension is like the first list, and then inside of it we have like a nested lists. And now we can access each element inside of our two-dimensional list by using the indexation as we did before. So and the idea here is that we can like we can open the first like brackets for the first list and put like 0, and this means that the first element of our list. And since our first element is list itself, we can, for example, just like print it in this way in the beginning, just to take
I'm sorry, do you share the screen?
Because... Okay, yes, sorry.
Yeah. Yeah, thank you.
Yeah, welcome. Okay, yeah, thanks for saying. So yeah, basically, let's go over like in the same way. So we can like create a list as we did before. So this is our like list, just like general plain list, and we have like five elements here. But then we created the two-dimensional list, and here, so the first element of our list is another list, and this is the first element, this is the second one. And now, for example, I can like access elements of my two-dimensional list by using the indexation as we did before. So here I use like 0, which corresponds to the first element inside of our list, and in this case it's gonna be a list of 1, 2, 3. And now let's just print it to take a look that it's like indeed the first list of our two-dimensional list. And you can see that we got as a result nested list. And now, for example, we can like go further and access the element of this list itself. So, and to do it, I can put like another like pair of brackets and specify the element that I want to fetch from the two-dimensional list. And in this case, we will get like the value 1, because this is the first element of the nested list. So, and let's just execute it. And you can see so that we indeed got the value that we tried to get. And then you can just change indexation. So for example, you can specify 1, 2, and in this case we will access the second element of our list, and inside of it we will take the third element, which is 6. So let's save this file and let's run it. And you can see that we got like 1 and 6 as the results in this particular case. Yeah, and also I have like some kind of visualization where I'm trying to also visualize how it looks like. So basically, let's think about our two-dimensional list. And in this case, we created a list, and we have like 3 nested lists inside of it. And basically, so this is a, you can think about it as a the first list, and then this is a first element of the general list, the second element, third element, and this is an indexation for the first list, and this is an indexation for each nested list that we have. In reality, so you can put like not the same length objects. I mean, like, so this list could have like arbitrary lengths, but in this case we kind of built a matrix. So you can think about it as a matrix where you have like rows, columns, and usually matrices, they're like rectangular. This particular case is like a square matrix where we specified values from 1 to 9. And then, so whenever we using the indexation, so for example, in this case, we use like 0, 0, and this like, you can imagine it that the first index corresponds to the general list that you had like in the beginning, and then the second indexation corresponds to the nested part of your original list. And in this case, so 0, 0 corresponds to 1, and basically, so this is like as a visual representation of the two-dimensional list that we had, just like for the kind of to provide you some visual insight of how you can like think about it whenever you like trying to solve some tasks. You can always try to imagine the two-dimensional list in your head. And then if you want to get another value, so this is a 1, 2, and basically so 1 corresponds to this indexation and 2 corresponds to this one. And in this visual representation that I gave you, so basically you can like try to make your own cartoon, but in this particular case you can see that the first index corresponds to rows in this part, I mean like in this representation, and the second one corresponds to columns. And we really can think about it as a matrix where we provide indices, and then we have like entries of our matrix. And yeah, this is a just like example how we can specify it manually by really specifying manually each value of our two-dimensional list. But in reality, so we can like use the list comprehension syntax that we saw before for creating different lists. So let's just try to do it. I will copy and paste the example from the website, and let's just go over it. So in this case, we specify two variables n and m, and we assign 5 and 10 as the values for these variables. And let's think that the 5 corresponds to the number of rows that we want to have inside of our two-dimensional list, and m corresponds to the number of columns that we want. And then we can create a two-dimensional list which full of the zeros. And so basically, as you remember, this is each particular element that we are going to put inside of our list. And this is in general list comprehension. And as you remember, when we have like a list and we multiply it by some value, we're gonna like just repeat this value this amount of time, and we will get the final list as a result. So basically it's like as a repetition of the element, and we will get in this case 10 zeros because m is equal to 10. And then this is like our iterations, how many elements we want to put inside of our list. And in this case we will put 5 elements, and basically we will put 5 lists, and each list has length of 10. And basically in the end we will get a kind of like a matrix with 5 rows and 10 columns. So let's just execute this part, and you can see that we got a two-dimensional list where we have like just zeros as entries of our two-dimensional list. So and usually here I ask the audience about in case if you already saw it. So have you seen the matrix multiplication, how it like looks like, the formula for it?
Matrix multiplication.
Yeah, so if you have like two matrices, there is a rule how to multiply.
So like you multiply one by another, yeah?
Yeah.
Yeah. There are some rules. Yes, I remember. like, but not distinctly, like.
Okay, so let's
Yeah.
then do the following thing. So let's just Google it and let's try to implement it. I mean, maybe it's kind of a bit complex task, but still, so this is our aim. So if you have like two matrices, because I saw that you have some like introductory course to the linear algebra or something like that, right? So do you?
We
Yeah,
have.
we have it in questions, and we well, oh my God, sorry. When we should prepare for entering the university, there were questions about kind of these things.
Okay, so in general.
Yeah, multiplication of matrices. Yeah, I also remember. Yeah, but not clearly. Yeah.
Okay, then
I
let's.
remember that this multiplication is not commutative.
Yeah, that's right.
I
That's true. That's true. That you cannot like. I mean, like the a multiplied by b is not always the same as the b multiplied by a. It's one of the features. Yeah, but basically, so okay. Then if you in this case, let's start with implementing some simple things. So, and in the end, we will perform multiplication of matrices. So let's assume in the beginning that we have like two matrices A and B, and they have similar dimensions. So basically, that the dimension of A is equal to dimension to B. It means that we have like the same amount of rows, same amount of columns. And let's implement some simple operations like the sum of two matrices and the division of two matrices. So basically we will need like to specify the matrix A, and let's in this case let's specify it like as a 2 by 2 matrices, so something like that. So this is an example of 2 by 2 matrix. And then so let's say that we have some other matrix, I don't know, let's just put it as a negative version of our original one, and our task is to calculate another matrix which supposed to be the result of A plus B. And so basically you can create it as a zeros in the beginning. In this case you will have 2 by 2, and then so the idea is like to go through the matrix C. So you need like to use the for loops, like iterate through the indexations from of the rows, of the columns, and fill it with the values. So basically you need like to put here like proper something, some proper arguments for range function, and then for each value of C of I and J we should put some result here also. So basically your task for now, like it's try to implement it and like to put all parts that are missing in this statements. Yeah, so basically you have time, you can take a look on it and try to implement. So let's try to implement it, and then if you, I mean like let's spend from 5 to 10 minutes on it, and if you still have some problems, we will solve it together. So, but and while you're like working on it, I will just like kind of bother you with my talking on the background. So why it's like even important for us to perform all these like matrix multiplications, matrix like sum of the matrices. So in reality, basically, whenever we work with the, in our particular case, we will work with the gene expression data, and the way that they are represented, it's usually a spreadsheet, right? So we have a spreadsheet where we have like a lot of different values. Sometimes it's a float values which represent the expression values for genes. Sometimes it's integer numbers, but in any case, so we can think about it as a two-dimensional matrix. And the idea is that, for example, then sometimes we want like to perform like a kind of as a reversed operation for multiplication. We want to represent our original matrix in the form of kind of, we want like to find two matrices which we can multiply and get roughly the original result. And so basically it's an idea that this multiplication plays an important role in general for some kind of baseline understanding of methods that are used for analyzing of the matrices and gene expression data particular, but in reality, so everything that we are analyzing in our life usually represented in the way of the matrix. So for example, if you are like working with the images, you can represent image as a matrix. So usually it's like a very straightforward way. If you have a image, this is a two-dimensional array of the pixels. Each pixel has intensity. So if the intensity is high, then the color is like similar to white. If the intensity is low, it's like mean that there is no light in this particular area and it's like dark area. And this is usually a two-dimensional list for the grayscale image. Also, it can be the text. There's operations how to transform text to the vectors, matrices, and basically, yeah. So okay, now I'll not bother you, so you can like just take a look and try to solve this task. So guys, maybe some ideas about even how to start.
Well, the idea is if we are summing up these two matrices,
Yep.
yeah, looks like that this C with I and J, yeah,
Yeah.
like the equation that you started, yeah,
Uh-huh.
the last line, I mean,
Okay.
should be like A IJ plus BIJ.
Sounds reasonable for me, yeah. Yeah, why not?
Yeah, but I was stuck in these ranges, you know?
Yeah.
For I in range, I thought it would be like length of some list, yeah?
For
I
example,
wanted
yeah.
to put something like len A and len B, but doesn't work.
So yeah, this is an important part, like in general, usually like to understand about the iterations. So, and as I said, we can think about that I corresponds to rows,
Yes.
and then J corresponds to columns. So, and then here we see that we have like I in range of len 2. So, and basically, in reality, even we can like, for example, for this particular case, start with something simple. So we know that the final result is gonna be 2 by 2 matrix, right? And in reality, we can put just like
So you just
2
write
and 2,
2.
for example, just as a first our solution. And let's just print the result. So and here I used like for loop, and I am like iterating through each element and see, and basically element is gonna be one-dimensional list in the end. So this I'm gonna comment. In reality, let's just remove everything which is not like related to the task that we are like resolving now, and let's just run it. So and you can see that we got as a result that each entry in our matrix C, kind of matrix, is 0, and it's like indeed what we expected, right? Because when we sum up these two matrices, let's try just to make it more clear. So the first matrix is 1, 2, 3, 4, and then we want like to sum it with matrix which is -1, -2, -3, -4, and basically so we will sum up these two values, we will get 0, these two we will get 0, this one, and so on. Okay, but now so in reality we usually want to make our solution more universal, to cover more cases, and this one is like some specific. We hard-coded here like 2 and 2, but in reality so we know that the number of the rows should be the same as the number of rows in the matrix A. And to get the number of rows, which are like, in our case, it's the general list length, because we have like in our A list, so this is, we think about it as a first row, and then we think about this part as the second row. And when we use len of A, for example, or in this case len of B also gonna work, this will give us as a result the 2. And then for number of columns, usually this is the element. So this is like, we can think about it as a first column and the first element of our column, and this is the second element of our column. And then we can put here like len of A0, for example. Because we will have
and what is the length of A element 0?
so basically
It's 1?
yeah, so this is a first element of our matrix, right? And length of A of 0 is gonna be 0, 2.
Yeah.
So let's
makes sense. Yeah, I see.
let's just check it. So when you can see that we changed it a little bit, and now everything still works the same. But now, for example, we can make it not a square matrix, but a rectangular matrix. Something like that. And then let's add here, for example, 0, 0 to make it not like a reversed of A, but something different. And now let's run it, and you can see that we got like a error here. And basically that means that we made a mistake. And now we can like take a look on the solution, try to realize where is the mistake that we made. So this is also kind of good exercise. Try to find the error.
Yeah, the arrow. Yeah.
Yeah.
I think we need another index like I, J, and K, for example, because we have 3 positions. Oh, no, sorry. No.
Yeah.
Mistake.
No worries. I mean, like. So basically, here we started from A and B, and then at some moment we created the matrix C when we're gonna store our values, right? And I didn't change anything here, right? So it's basically still the 2 by 2 matrix. And to resolve it, we need like to also somehow adjust these values here. And we know that the number of rows should be the length of A, and number of columns is len of A of 0. So now, hopefully it should work. Yeah, and we got the result. So basically it's like about the summing of 2 matrices. And in the same way, we can perform like a subtraction. So for example, D is equal to I minus B. So when D is equal... Oh, here is like slightly different, strange. I mean, like we can just right away put it in this case. As a list without zeros equal to something. So D is the same, and then, for example, I'll just copy and paste this part. But Dig is minus Bij, and this is a D. So let's make it a little bit more transparent. I'll add one more line. So and here we just like performed like a subtraction. And this is a point about how we should like try to think in reality. So yeah, when it was like 2 by 2, when it was like a square matrix, we could just like hard code it if we know that it's like always 2 by 2 case. But in reality, sometimes like we work like with different shapes of matrices, and we want like to have a solution which is a generic one that we can apply it for different matrices. And now, so guys, the task is like to perform a slightly harder, like to resolve a slightly harder problem. And I like asking you not to look on the solution right away, which is provided on the website. There is a question about how to perform a matrix multiplication. So, and this is a wiki page about the matrix multiplication, and basically this is a slightly harder part. So in case if you have like two matrices which are like A and B, you can see that the shapes are of two matrices are different. So A is a M by N matrix and B is N by P matrix. And when we calculate the result of A multiplied by B, we will have M by P matrix. So yeah, it's like there is like in general usually a point which I still want like to somehow provide an explanation why the matrix multiplication looks as it is, but I still didn't finish this like part on a web page on a website about why it's like so strange. I mean, like it can be like you can look on it and then you like why it's like not like just element wise multiplication, why it's like some different shapes of matrices and the result is different, but there is like some idea behind it why it's like in this case. And our task for now is to calculate the matrix product, which is matrix C, and this is like a formula for each entry inside of the C matrix, how we should calculate this matrix. So and the task is like to calculate the matrix product by using the Python with two-dimensional lists. But guys, maybe someone has like a strong math background. So do you know why like matrix multiplication looks as it is? And don't be shy. Like I mean, like, if you just have some ideas, you can just drop them, you know. So on the linear algebra course that you have, you already saw some. I mean, like you have definitely the kind of math for beginners or something like that, right?
Yeah, we have this discrete maths.
No, discrete math, I believe it's like another part. So it's like more about some set theory, something about the
combinatorics.
Yeah. But also I think that you have like a course where you start from like, for example, the calculus, where you calculate the limits of something, some mathematical induction, no? And also at some moment there's supposed to be some part of the linear algebra about I mean, like what are like vectors? What are the vector space methods?
Yeah, we were supposed to prepare it before we entered. Yeah, so
okay, I see.
Vectors, and this topic was also included. Yeah, but.
So okay, then I have a question, like just for you guys, and everyone can answer. So when during your like preparation for entry exam to the course, when you were like looking on these matrices, so what were your like thoughts? Did you think that it's like relevant, or maybe you thought that why I should like even bother myself with some matrices during the preparation for system biology, which is like biology and not matrices at all?
Yeah, well, it's quite kind of difficult to understand if you don't know the practical application, like where is it used?
Okay, yeah. So basically this is a point that whenever you see, like in my case, for example, if I see just like a plain formula, raw formula, then it's like, yeah, I mean, like, who cares about A, B, why is there like there? But in reality, yeah. So in my mind, so especially because in the beginning of your first term, you definitely saw the Fantasu set, and I usually kind of refer to it. So if we open a data set here, yeah, while you're like working on the implementation of matrix multiplication, so this is a typical representation of the gene expression data, and in this case, it's I believe a microarray data. But what is like very interesting that for RNA-seq it's gonna be similar. You will have a two-dimensional spreadsheet with values. So you can see here we have like a values. So for example, for this particular one is like 1126.9. This means the expression of the gene which is ZK-scan3 for particular sample BMDM interferon gamma 4. And for RNA-seq it's going to be something similar, but the value can be integer in the beginning. But idea is that it's two-dimensional matrix, right? And for example, right now you can adjust it. This is a kind of another process. We are not like working with two matrices or something like that. So let's just like adjust it. So we will perform like 1 plus log 2 normalization and also quantile normalization. Okay, I got it. Then let's just filter out all lowly expressed genes. To do it, we need like to create a calculated annotation. We want like to calculate the average value for each row. And during our course, we will try to re-implement something from the scratch by ourselves. So we will also try to calculate the row mean for each row inside of two-dimensional list. So as you can see, we calculated it here, and now we have like an average value for each gene in our list. Okay, now I just want to filter it, and it's not relevant to matrix multiplication yet. Let's just filter by mean, and I want like to keep, for example, I don't know, 8k of highly expressed genes. So, and this is my, we can even like take a look on the data here, and this is our like two-dimensional list. We can think about it as a two-dimensional list matrix. And now, for example, if you perform a, there is a, yeah, so plots. If you perform like a PCA plot, which means that you perform like a PCA reduction first. So we performed it, and here you find like PC1, PC2. And in reality, what happened, you tried to decompose your matrix. So basically you found two matrices, and the product of them equal to your original, kinda equal to your original one. And the idea is that you now found like directions in your like multi-dimensional space. So you found directions by rotating your original data. And rotation, it's a operation. And when you want like to specify some operation, some linear operation, you need to specify a matrix for that. And basically, whenever you multiply two matrices, you perform some operation over the space. And this is why it works in this way. So why this like strange equation appears? Because in reality, so when we go back to the equation, in case of B, for example, it could be just like one vector. So you can have like just one vector B without all other columns. And then when you multiply A by B, you perform like some operation over this vector. You can like, for example, stretch it, or you can rotate it. And basically this is the idea of two-dimensional like lists, matrices, and like products. So that it's like really relevant to the analysis of the data that you have. And we will try to kind of accomplish some simple tasks, try to mimic some solutions that are provided, for example, on the Fantasus web page. So guys, what about matrix multiplication? Have you tried to implement it? Do you have any ideas? Let's just create a new file. Let's call it matrix multiplication.py. And now let's specify two matrices. So A is gonna be, and we can start with something which is known. I mean, like we can start from some like simple case also, or with some another one. So basically, as you remember, if we have like dimension of A is n by m, and dimension of B is supposed to be m by p, and the result of A by B, it's n by p. So let's specify matrix A. So for example, 1, 2, 3, 4. And for B, we can put it in the way that we have now. It's hard to come up with some values, but okay, let's put some random. 4, 8, 6, and I don't know, 1, 2, 3. So now we want to calculate the product of these values. And let's just take a look that the input indeed correct. So here we have like 2 rows. So that means that we have 2 by 2 matrix for A. And here we have 2 by 3, right? We have 2 rows, and in each row we have 3 elements. That means we have like 3 columns. And the result that we're gonna have supposed to be 2 by 3. And the idea is implement the matrix multiplication for this case. So and we can start with something simple. So let's again just initialize the matrix C. So here is something. We should put some value here before for E in range of something here. So guys, what are your like suggestions? What should we put? So C supposed to be 2 by 3. And let's just get these values from the matrix A and B.
Yeah, we could use this for loop because we have the sum, yeah, and k in our sum ranges from 1 to n in the formula, I mean. And probably we could like do this for loop, yeah, and for k in range 1 to n, yeah. And what is n in our case? Yeah, let's we need to understand, yeah.
So okay, yeah, for now we just want to initialize like a matrix which full of zeros, like a zero matrix.
Okay,
yeah,
okay.
and then we will go like to the real
Okay. So
implementation
what do we
for,
write here? Yeah. So for I in range.
yeah. So what should be here?
This will be length A.
Yeah, and here. So what should we put?
And here it will be length of the first element. No. Yeah.
Of A.
Yeah. Of.
A0, something like that.
First element of this one.
Okay, so let's just print C, just like to make it more clear, transparent.
Yeah, can't we just write print C and that's it, no?
We can, yeah, but in this case it's gonna be, let's just check. So it's gonna be in one line, which sometimes
okay.
not so transparent, but it's also possible. You can just like, write it. But in this case,
well,
so we got.
Why does it jump from line to line when you do it for element in C?
Why it jumps? So because print by default print has the end argument, which is equal to new line symbol. So basically it's the same as have this one. So we go through each element in C, and then after print ends in the body of the loop. So for example, it was the first iteration. We printed and then we added the new line symbol, and then we go to the next element. Yeah, and so we can see that it's not as we expected, right? We want to have like 2 by 3 matrix, but now we have 2 by 2. So basically, we supposed to work on this part somehow.
Yes, because we use the length of the element of A, and it should be probably B. Yeah.
Probably, yeah. Let's just check it. So yeah, now we have like, for example, at least we have the original matrix which we're gonna fill with the values. So yeah, and now we need like to go through the something here for something here, and then maybe even something. I mean, like just in the beginning we need like to start with these ranges. So and basically the idea that we want like to go through each element inside of the C matrix and then put like some value inside of it.
Yeah, actually, well, if you use the formula, we know what is k. Yeah, it ranges from 1 to n. And what is n? N is the number of what?
You mean
of elements?
you mean here?
Yeah, in the formula. Yeah, like.
So yeah, basically
this,
k is
in
like
a
from
k,
1 to n. It's like the number of like rows.
Number of rows in what? In B, in A, or in probably it's
In B. So for example, in B, or it's number
in
of
B.
columns in A. So I mean like it's can be one from here or like one from here.
Yeah. Okay.
So yeah, and in reality, so we need like to
So
start.
it's the length. Then it's the length of this A. Yeah.
So
length of the element of A. Right.
kinda. So let's
Yeah.
so the idea is that we want like to write Cij is equal to something, and so in the beginning we need like to handle I and j. So and we know that we want like to go through the matrix C in this case, and here it's supposed to be len of C and len of C of 0. We just want to go over each element in Cij, put something, let's then again print the result. Just to take a look that we went through the matrix, we changed the values, but now, yeah, so we need like to implement this part. So you can see, so Cij is like a particular element inside of the matrix. And to calculate it, we need like to sum the values as it expressed here. And to do it, yeah, we need like to go through each element from 1 to n. And in our case, it's same as the length of the b. So when we can write it for k in range of len of b, right? So if I make some mistake, you can like yeah, kind of argue. And then so we need like to put Cij inside of the k loop, and now in reality, so Cij is equal to plus equal of the ai k multiplied by b kj. So I believe something like that. So let's just take a look, think about it, and if you have any thoughts about it, just let me know.
Yeah, just a question. When we have this loop for k in range of length b, why is it length b? And
here?
Yeah.
So as you can see, we want like to go from like through the kind of, in this case we are going through the
from 1 to in each column,
in each row. So we have like rows, we want like to go through the row, like through the, I mean like this type of direction. So it's like 1, 2, and you can see that the n, and basically this is a length of the rows inside of b, and to calculate it, it's like len of b. Right?
Okay.
So, and let's just try to run it and see if we have like any errors. And this is the result that we got. And let's just validate it. So, guys, do you have any ideas how to validate it, that we like calculated something real? Yeah.
Just check for some numbers, random numbers.
Yeah, for example, we can check it with some numbers. And so in our case, we have two matrices, 1, 2. And when we calculate it, so basically how it works, usually when they explain the matrix multiplication, how you calculate it on a paper, so you need like to take a row. We took this row, and you kind of hard to without, you know, do you have like a whiteboard? Okay, I'll try to Okay, they're like asking a lot of information from me. Okay, in reality I can use so okay, the idea is that we have our values a, y, it was m, for example, right? What it was? Oh, it was n. So it was n, and we want to multiply it. So basically this is our first matrix. We have all these like values here, and then we want to multiply it by b11, and then what it was, b1p, and then here we have bn1, and here we have bnp. So, and how it usually works, so you think about it as you took the first row, then you put it next to the first column of the B matrix, and then you multiply all these values.
And when we
And
multiply
sum up.
these matrices, should the length of the first row of A be equal to the number of rows in B?
Yeah.
So it's always like this, yeah? So you can't like
So basically,
multiply if they are different.
yeah. It doesn't work if they look different. So the number of elements here should be the same.
Should be equal, yeah.
So basically we multiply it and then we sum up them. So it's like A1, B11, A12, B21 in reality. This is a mistake. And then like up to the last element, which is A1n, Bn1. And basically this is the formula.
Then you do the same with the second row and the second column.
So the next one, so this is when we calculate it, it's gonna be the first element. So this and
this whole sum is the first element.
Yeah, this is the first element. And to get the second one, we take this, this again, and then we multiply it on the second.
By the second column.
Yeah, by the second column, and then it's gonna be the second element, the sum and multiplication of them, and then we fill the full matrix in this way.
Yes, I see.
So yeah, okay, and basically, as you can see, when we have here, we have like a first row, it's like 1, 2, and we should multiply 1 by 4, 2 by 1, and it's like 4 plus 2, and it's 6, and we got 6. Then we take the same row and we multiply it by 8 and 2, so it's like 1 by 8 is 8, and 2 by 2 it's 4, and 4 plus 8 it's 12. And then we do the same for the, we multiply 1, 2 by 6 and 3, which is 6 by 6, so looks correct for me.
Yeah, actually we could write it as a code, this checkup.
We could, but so in this case we need like to kind of, it's like usually, for example, how it works with a testing system on a static. So I need like to, for example, manually specify the correct solution for specific test. I know that if the input is this one, that the result supposed to be this one, and then this is how it works. So yeah, we just like take the kind of solution which was provided by someone, and then we check if our program works properly with these values. Then we can like just, I don't know, play around, change it a bit. So for example, multiply it, and there is a case that this is what I specified is called identical matrix. And when you multiply by this, if you multiply this matrix by something else, you need to get as a result B without any changes. And you can see that we got indeed B without any changes. So yeah, this is about matrix multiplication, guys. And I really, so it's hard to, because I didn't I didn't like finish this part about matrix multiplication on website, but in my mind it's very important, and I need to find time and somehow provide some visual representation and explanation, maybe also referring to the gene expression data to kind of make it a little bit more clear why it's happening in the way as it is. Yeah, but yeah, so it's like very crucial because, as I said, for example, in case if you perform like a PCA reduction, in reality, right now we calculated A by B is equal to C. But there, usually, we try to find two matrices. So let's call A prime and B prime. So we want like to find such two matrices that gonna give us as a result C. So we know C, we don't know A prime, B prime, and in PCA, so what happens? We like trying to find A prime and B prime, and there are like some assumptions about, for example, B prime. So it's supposed to be a rotation matrix, and rotation matrix there is some specific features about rotation operators. So yeah, and it's in my mind important. So this was about two-dimensional lists. So we will have like definitely some tasks about two-dimensional lists. So you will get like much more comfortable with working with the two-dimensional lists. And now let's just switch to another part. So another thing, it's dictionaries. Yeah, so and you can even take a look on an answer here. So looks pretty similar in my mind, but some arguments could be kind of swapped because A and B should have like some specific features, and because of that, instead of len A or len B 0, we can specify something else. Okay. Yeah, about dictionaries. So dictionary is like another data type which is built in Python, and it allows us to have something similar to lists. But in lists, as you remember, we have like indexing. So we have like the way to access the elements by using the index of the element. And indexes, they start from 0 up to the length -1. And in case if you need like to have, instead of the index, some kind of reasonable value, we can use the dictionaries. And this is an example how can we specify the dictionary. So it's dict.py. So, and here is an example. So let's adjust it. It's not anymore 29, unfortunately, right? And the case is that, so how it works? We specify the variable name here, and then there is a syntax to specify a dictionary. So and basically I open the curly brackets here, and then we specify the name. It's like as an index, but instead of the index, we can then refer to the elements by using this name. And here, like instead of here we specified date of birth as a name of the element, and the element value we need like to put column symbol and then specify the value. And as you can see, so it can be the value can be string, number, whatever. But there is one requirement about the key. So and basically, yeah, left part called key and the right part called value. In the same way, you can put it in one line, so it's not to be always on new line. So in reality, you can specify it on one line in the same way, and then H is 30. So basically, it's like same things. Okay, now let's just run the program. And this is a output of it. And then, so if you want to, yeah, so this is a important note. So the key inside of the dictionary always should be immutable object. We cannot put mutable object as a key for the keys. So it's like just as a note, and we need like to remember it. So yeah, and then, for example, we can just access the values inside of our dictionary by using the following syntax. So we open the brackets, square brackets as it was before, and now instead of the index, before we were using index, we will specify a real key, and in this case, for example, I want to get the name. And you can see that we got the value which corresponds to the key name. Then in the same way you can specify another key, for example H, and you will get some value. Later on we can reassign the value. So for example, let's change as it was before, so that it was 29. Now I want like to change H, and I want to increment it by 1. And then let's print person H one more time. And you can see, so in the beginning it was 29, and then we can use this syntax to access the element, and then also reassign the value for the element. So yeah, you can take a look on some notes here. It's like about that ordering of the elements, but yeah, this is how we can like modify values. We can create a new key value pair. In this case, you can see that we created a key which is interests, and then we put list as a value here. And so, for example, for this person, he has such type of interest. So he likes probably photography, chess, and then we can print the person, like the whole dictionary back to the output. And you can see that we added a new entry to the dictionary. And now, so we can like iterate, because all iterable objects, they are somehow similar. The idea is that we can iterate through the elements of the dictionary. And let's check how it works with dictionaries. So in this case, we need like to use the for loop. And as you can see, so here I put for k in person. And basically, when we use for loop with dictionaries, by default in this like statement, we will go through each key inside of the dictionaries that we had. Let's just run it. And yeah, I'll just probably comment this part, not to get a lot of other stuff which are not important for us. So you can see that we are iterating through the keys, and the first key is name, and then to get the value which like corresponds to the key, we need like to write person, and like as an indexation we put key instead of the index here, and we get the value is Vladimir, then the next key is date of birth, and so on. So guys, is it clear?
Well, not quite. Like, what is the purpose of this operation?
Which one? Iteration?
Yeah.
So iteration usually it's like because, for example, we can. The idea is, for example, we want like to change all values inside of the dictionary. So let's say that we had like some string. So let's say that I have line.
Yes.
Something like that. And then, so for example, I can create a dictionary, and let's create it as a empty dictionary. So, and let's call it like D. And I will use a specific function dict to get the empty dictionary. So let's print D, and let's just run it. So you can see we have like an empty dictionary. And now, for example, I can go through each value in our line and for example, now so this is basically the idea. Now, right now we are like iterating through the line, but after that I will show you why we need like also to iterate through the dictionary as a next step. And for example, if value in the keys, so this is a method which gonna return us the keys of all keys inside of our dictionary. Then we want to continue, and else we want to put d_well is equal to line count value, and let's just print d. So, and as you can see, so what we did, we counted how many unique elements inside of the line. So there are like 3 A's, then 3 B's, 2 C's and 4 D's. But now, for example, let's say that someone provided you adjusted line, right? You know that, for example, there are like the same keys, nothing changed. And then you can, for example, go through each key in the dictionary, for key in D, and then dk is equal to line count dk. Something like that.
Okay, and well, we created this dictionary, yeah? D is equal to dict, yeah? Using this dict operator.
Right.
Yeah, and then we were going through different values in our line, yeah?
Yep.
And our dictionary used to be empty.
Yeah.
And like,
And this
yeah.
yeah, and this statement will add one by one new key value pairs to our dictionary, because as you can see, so if we already have if we have like a character as a key inside of our dictionary, we will just go to the next iteration. But when we have like a new value which we haven't added to the dictionary, we will add it to the dictionary. And then, so this is so this is not a perfect example, but just as an example that sometimes we want like to go through each keys that are inside of our dictionary and like, for example, perform some changes, or sometimes we just even need like to print it and that's it. So we don't need like to modify in any way the dictionary, but sometimes we need like just to, for example, print it in more nice way instead of the default one if we use just print. So for example, we want like to put it for example, if you want like to perform like some formatting, so for key in D, and then print key is K, and then for example value is DK. Okay, I removed some line, right? Okay, so let's comment this part and let's just execute it. And this is as an example that we used like also iteration, and then we kind of get a pretty print output. Yeah, this is just as an example when we need iterating over the keys. And basically we also can iterate just through the values. In this case, you can use the values method with dictionaries, and also you can go through each key value pair by using the items function, items method. So let's just print, copy and paste this part. So here we specified K and V, and basically each item here of this iterable object will provide us K value pair, and then key value pair, and then we assign them to the variables key and V, and then we print them. So, and this is the results of it. Yeah, this one I can remove. Yeah. So there are like kind of different ways of iter through the like how we can iterate through the dictionaries. And as always, it depends on the task. So sometimes we want like to go through the key value pairs. We don't want to write person brackets k, and this is a much more compact way to have like a value right away instead of writing person k. Yeah, also you can check that the key is present in the dictionary by using the in operator as it was before. Yeah, and in case if you are trying to get access to some value, and so for example, if you don't have the country as a key inside of our dictionary, we will get an error. Yeah, and this is a nice way of the specifying the dictionaries. In case if you know that you want like to specify a dictionary by using some recurrent formula, some iterative process, you can also use as a list comprehension, but instead of the square brackets, we put curly brackets here, and then we specify some range for our iterations. And then to specify the key value pair, we put like key and then column symbol, and here is the value which corresponds to I. So let's copy it. I'll create a new file and let's run it. And you can see, so here we created the key value pair. So for each character, so basically chr function return us the character which corresponds to specific code. So there is a, I believe it's like NCI NCI encoding for letters, characters, and basically when we use this statement, it's gonna return us the letter which corresponds to specific number. You can later take a look on the internet. And here we created the full list of the letters. Yeah. Yeah, so there is like some information about it. Yeah, this is basically, we already did it, so let's skip it because this is a task about how to calculate the frequency of all unique elements separated by white space. It's slightly different, but idea is the same. So in the end of our lesson today, let's also briefly take a look on the sets. And yeah, so guys, one thing that I didn't mention, so dictionary itself is a data type, built-in data type in Python. And basically, as we saw before, for each data type you have like some methods which we can right away use with objects itself. And for example, for list it was like we can append, we can extend, we can like I don't know, pop elements. And for dictionaries there are like some other methods that you can find in the internet, like by looking what kind of methods dictionaries have. And the same for sets too. And sets, it's like a mathematical set, so it's like unordered collection of elements, and each element inside of the set is unique. It means that there is no like duplicates of anything inside of the sets. And here is an example how you can create a set. So we also use the same type of brackets, and then so we don't put like a key value pair, we just put values. And then we have a set. So here is our example. So we created a set. And the nice part about it, so for example, if you have digits as a set, and let's say that I somehow randomly put it 3 zeros. And you know that in the set, we don't have any duplicates, and this is a nice part about it. You can check that something inside of the set by using in operator. Then you can like also use not in. There are like some methods for sets. You can add element to the set, you can remove all elements from the set, you can get the copy of the set, and you can remove specified element. Yeah, and also there is like operations which are like natural for sets, so you can calculate, you can check whether like two sets are equal, you can get the union of two sets, you can get the intersection of two sets, you can get the difference, you can check that the one set is the subset of another by using all these operations. And then also there is a iteration through the set. And also one thing that I sometimes like forget about saying, that you can always try to play around it and, for example, try to perform like some type conversions. And in case, for example, if you had some characters, right, as we had before, then you can create a set of it. So for example, say like characters is a set of line, and then print characters. And you can see, so we got like all unique elements of our line. And that means that you can perform type conversion from string to set. Also in the same way you can convert list to sets, or even like then if you need, like for example, get the unique elements and then at some moment to fix the order, because right now the sets, they're like unordered, there is no order here, right? For example, so we start from B and A goes after B, but in case if you need like to sort them, right, we cannot write I believe we cannot write sort, or for example we cannot write sort. Yeah, so set object has no attribute sort, but you can also add conversion to list, and then you are able to sort it, and then you have like all unique elements, but also you sorted them in a lexicographical order. So yeah, that's it, guys. That's it for today. We did through it, right? So yeah, basically, as I said, guys, I will put a new homework, and it's gonna be about lists, tuples, and strings. So I will put it like during this weekend. And there is a point. So I'll be traveling next week from Wednesday. So and basically we will lose our like typical time slot. So and because of that, I will probably at some moment make a poll in the Telegram about like to find another like time where we can have lessons. Yeah, okay. Because like a spoiler, guys, spoiler, the next topic is amazing. You're gonna love it. You're gonna love it. So functions in Python is like something very cool. It's like, and after that, after like functions, you are able to perform like a lot of different things, even in terms of the gene expression data. So I will basically make a lot of tasks for functions, which will very, in my mind, helpful in case if you resolve them to understand some basic operations that are happening on the background when you're like working, for example, even in the Fantasius app. So yeah.
Okay, and I'm sorry, yeah, as I have not solved some tasks yet, can I use like functions or something from like what we have not studied yet?
So in reality you can, yeah. It's not like
it's not a problem, yeah?
Yeah, it's not a problem, but sometimes maybe it's like just as an exercise, try to, for example, solve some tasks without using functions. So for sure, in some cases, I like manually prevent. You will not be able, for example, to utilize some very cool functions from the NumPy module, from the pandas module, from the statistics module, because the point of some tasks is like to resolve them yourself.
Yeah,
but
okay.
But for those tasks, you will just faced with a problem in case if you're trying to, for example, import some module like as a NumPy. you will face
No,
with
no, not that complicated.
Yeah, yeah. But yeah, for other things, so for example, if you need like to calculate the sum of the elements inside of the list, yeah, you definitely can use sum function. And in reality, so if you can also, for example, if you solve the task and you think that, wow, this is like something very impressive. I mean, like, I'm proud of myself. I made the in very like, for example, short way. You can then share it. I mean, like maybe not just as a solution for the task, but maybe just as a some like usage example in the Telegram chat channel. So yeah, and for example, in case if you need like to calculate the sum of the elements, if you have like a sum list, or even let's try to make it a little bit more automatic. So I want like to calculate sum of elements of the list.
From what to level?
Yeah, from 0, 1, 2 up to 10. Right. So in this case we
10.
can.
Okay.
Yeah. in this case we can use the sum function. So and we got the result. And basically, yeah, you can think about it as values is this one. That this is our values, and then the sum of values is equal to sum of values. Something like that. So yeah, there are definitely some built-in functions which can help you to accomplish some task. Or for example, if you need like to find the minimum of all values, you can specify the whole code to go through each element, but also you can find it right away by using some built-in functions. And as you can see, I even didn't import anything. I didn't like bother myself with adding extra codes. Yeah, but in the beginning I don't talk about them because in my mind it's also kind of good once to perform it yourself. Because of that I'm not like starting from there are like sum function, min function, max function, just like try to implement it, and then if people for example didn't Google anything, person gonna try to resolve the task like
some loops, yeah.
Yeah.
Okay. Yeah. Thanks a lot.
Yeah, welcome guys. So that's it for today. So I will text you about we will try to find the date for so we will probably miss 2 lessons because of that, but we will try to find another time and then be on track.
Okay.
Thank you.
Yeah.
Thank you.
Yeah, thanks guys. So I will see you, I don't know when, but definitely we will see each other again.
We will keep in touch. Okay.
Yeah. Okay guys. Bye.
Thank you so much. Bye.
Thank you. Bye.